Despite advancements in modern civilization, one fear still remains in the minds of scientists. The very thought of an asteroid smashing into the frontiers of the Earth sends shivers down the spine of many. Asteroids, also known as space rocks, have smashed into the Earth on several occasions. The devastating events they bring are so terrible that it leaves nothing but gloom behind. From life-threatening tidal waves to explosions that could wipe out the whole of human existence, asteroids and disasters go hand in hand. But things are even about to take a more drastic turn. NASA has discovered incredibly large asteroids heading straight down to Earth, and this is where NASA's DART gets to play the hero. Fully known as the Double Asteroid Redirection Test, this is the first planetary defense object to test the methods of deflecting asteroids on course to our home. What should you expect from DART? When would it be in full operation? Join us in today's video as we talk more about this. Before we move further, let's remind you to subscribe to this channel and hit the notification bell to stay connected. October 22nd, 2021 entered the pages of history as the day that a massive asteroid entered the Earth's threshold at an insanely fast speed. The said asteroid was dubbed 2021 SM3 and measured diameter of 525 feet. To paint the picture clearer, it is twice the size of the Egyptian pyramid of Gaza. For an object so large, it shouldn't be so hard to detect, right? However, things start to get creepy when this horrifying rock was only discovered a month into its impactful landing on Earth. In other words, if its direction had been slightly aimed at Earth, it would have been impossible to avoid its massive destruction. This would not be the first time Earth would be having a close brush with an asteroid. As a result, this called for quick actions from the scientific community. In response, NASA ventured into creating a highly dependable system to avoid the looming collision. This led to the birth of NASA's DART, and it was launched into space 2 months after the narrow escape from being struck by an asteroid. To execute their plans, NASA's DART was strapped to the back of the SpaceX Falcon 9 rocket and jetted out into space to face the formidable asteroid. Some weeks from now, we should start to see some actions come to play as the sheer force of the 1210 spacecraft will be put to the test against a predicted asteroid named Dimorphos. The intended collision will be happening at a terrifying speed of roughly 4 miles per second. If all goes as planned, this remarkable feat would modify Dimorphos' orbit around its bigger partner Didymos. In the wake of the collision, NASA scientists will be on standby to measure the differences as well as identify and observe how efficient the kinetic impact method of asteroid deflection is. If findings prove to be significant, then this method would be employed for future asteroid-related occurrences. However, from what is observed now, the impact should reduce Dimorphos' orbit by several minutes, even though accuracy is still prone to changes. Nevertheless, this would justify NASA's theory that a spacecraft can move and smash itself into a target asteroid without help. This conveniently brings us to the long-awaited question: how does that work, and what sort of highly advanced instruments were used by NASA in equipping it? Contrary to popular belief, the DART spacecraft is incredibly small compared to others in NASA stables. The spacecraft features a box-like core with 2 rolled-out solar arrays that give it a span of around 40 feet. Regarding its electric propulsion technology, DART makes use of a continuous flow of charged electric nuclear ions to achieve a light push. For it to be on the move, the spacecraft will travel around the Earth several times, employing its electronic engine to cautiously build the required momentum or break loose from orbit before heading out for Dimorphos. In the course of the long journey, it will most likely pass another asteroid named 2001 CB-21. Mind you, DART only possesses one science instrument dubbed Draco. Draco is a high-resolution camera that also plays the role of a navigation system. The inspiration behind Draco is drawn from a camera on NASA's New Horizons mission that made headlines for its flight near Pluto. DART will launch an Italian-based CubeSat to watch for its impact 5 days before it arrives. Since the main spacecraft will be too distant from the Earth for flight controllers to manage in reality, the spacecraft will convert itself to a self-navigating machine 4 hours before impact. In that instance, Draco's images will be transmitted to the spacecraft's computer to differentiate between Dimorphos and Didymos, while enabling it to move towards the latter. By employing an ultra-modern guidance navigation and control system, along with an algorithm named Small Body Maneuvering Autonomous Real-Time Navigation, best known as SMARTNAV, scientists can now compare the two asteroids while focusing on their final destination. Here is an interesting fact. Would you believe it if we told you the entire process involved in planning, navigating, and projecting would take just an hour? Yeah, it's true. The targeted asteroid is measured around 6.8 million miles from Earth and would be a long way far from the reach of scientists on the ground. To put it more simply, all processes involved are actually self-engineered by DART. After the entire process has been kept in place, DART would head straight for Dimorphos, altering the orbital period of Dimorphos around Didymos from 11.9 to 11.8 hours, a change of only 4.2 minutes. As a result, Dimorphos would have no choice but to gravitate to Didymos. Along with this, the project would transmit findings more quickly, after which they will be analyzed repeatedly by scientists at NASA. Whenever the ideal moment presents itself, there would be no cause for alarm since NASA has the best weapon for combating asteroids heading toward Earth. And if all doesn't go as planned, NASA scientists will have no choice but to return back to square one. The best deal yet is that scientists would now be able to differentiate data from Earth-based telescopes to decide on the previous and following events that took place after impact. This would help scientists study how much Dimorphos' orbital period changed. Hopefully, this one metric will provide NASA information on how the asteroid responded to the DART's deflection operations. What's more, the European Space Agency Euromission would dig more into the Didymos and Dimorphos mission a few years after the initiated impact. This would provide additional data for scientists to study. You see, what really did catch the attention of astronomers about the two asteroids is the distinct speed they move at. Dimorphos orbits Didymos at a much reduced speed, unlike any asteroid system they've come across. As a result, findings obtained from the DART testing can be easily measured. On top of that, the size of Dimorphos is so massive that it could be a threat to our planet. However, Didymos does not pose a direct threat to us. So rather than destroy the twin asteroid, the DART mission would give the smaller asteroid a little prod and direct it around the orbit of Dimorphos. To put it more clearly, there is no possible way to change the asteroid's direction to make it more threatening. Moreover, Dimorphos' speed would barely change by 1% when it rotates around Didymos as a result of its quick impact. Now, you may think this barely changes anything, but it would adjust the moon's orbital period for more than a minute. In fact, every 11 hours and 55 minutes, Dimorphos finishes an orbit around Didymos. Based on predictions from experts from the Johns Hopkins Physics Laboratory, if the hit is successful, it will shift the orbital period for at least 73 seconds. As a matter of fact, measuring a speed transfer between the spacecraft and Dimorphos would reveal how much energy is required to change an asteroid's direction. For instance, if an asteroid heading toward Earth is discovered one day, NASA would now know how much speed is needed for protecting the Earth. For now, there are no asteroids lingering around to smash into Earth, but you should know there is large congestion of asteroids in close proximity to Earth. They exist in various forms and sizes, and discovering them early is very important for us to survive. The aim of NASA is to change their direction towards Earth for a little set amount because changing the asteroid's orbital time alters direction. Even if this mission may take a long time to finish and process, we are happy to announce that it is progressing quite well, and we may not need to hold our breaths at the mention of asteroids. Thank you for sticking with us to the end of today's video. Let us hear your opinions about the DARTS mission in the comment section below.